Hello, hi. So welcome and thanks for coming to the second face-to-face lecture of Northwest Vienna branch. Very pleased to be able to introduce Ian White from Lloyds Register, who is going to give us a lecture on Lloyd's classification of the aircraft carrier Queen Elizabeth. Ian's job title is Global Naval Construction Manager, and I will pass you over to Ian.
No,
thank you, Ian.
No. Thank you very much. We are trying to do everything from one laptop this evening, so apologies to those online. I hope you can hear us. Hopefully that's a bit better now. Yes. Okay, good. So I am now going to share my screen. And if anybody comes in late, somebody's going to try and keep an eye out. So, all right, thank you very much. Come in. We've just got a few more stragglers coming in. So. Okay, good evening, everyone. Thank you very much for coming along, and thank you for inviting me. As Duncan said, my name is Ian White. I am the Lloyds Global Naval New Construction Manager for Lloyds. I am based in central Scotland, where most of the naval new construction takes place these days. My potential role is basically to help manage and support the Lloyds project managers who are building naval ships around the world, the projects we're involved with. But prior to that, I was the project manager for Lloyds Register on the aircraft carrier projects. So hence why you got me today. So this evening, there's a lot to talk about, and I can talk about it all evening, so I'll try and keep it short. It's Duncan's responsibility to make sure I don't. But we're going to quickly look at the background of naval rules, why Lloyd's naval rules were developed. We'll look at the carriers themselves. We'll look at a bit of some of the LR consultancy work we did early days. We'll look at the class notations that are applied to the carrier. We will touch on plan approval and the build aspects of the carriers, look at trials and commissioning, and then finally enter into entry into class. If we've got time and you're willing and able, we'll talk about the supply chain as well. Okay, so a bit of background. Well, as some of you may know, the Lloyds was founded in 1760 in Edward Lloyd's Coffee House in London. And then a few years later, the first rules were developed for ship construction and design. And then a few years after that, the first ships were built. But in those early days, in the registry books, there was a column for the number of guns a ship would carry. If you like, that was the first involvement, the first time we as Lloyds Register came across naval aspects. Now, okay, they were there mainly for self-defense, but that's, we have been involved with naval ships early days, but then there was a period where we just really looked after commercial shipping and didn't get involved with naval ships as such, really until about 30 years ago. But then since then, we have had quite a bit of involvement, and this slide shows, it's a bit out of date this, but shows some of the projects we have been involved, be it transfers of class, new construction. Early days, it was against the ship rules and maybe the special service craft rules, but since then, and the development of the naval, some of the projects have been undertaken against that set of rules. So quite a lot of history and quite a lot of activity we've been involved with, and of course, always looking at new projects and things coming along at the moment as well. But why did Lloyds Register get involved with naval ships? initially, constitutionally, we weren't allowed to do that. We kept away from it. But there were several driving factors that involved. One of the main driver, if you like, was money and budgets. Naval budgets were shrinking worldwide, particularly looking at the budgets for the Ministry of Defence shrunk. That had an impact on several aspects, one of which was their development of naval engineering standards, the DEF stands, the build regulations, etc. And the ability to maintain those standards, ensure that they are up to date and they are relevant to the ship design and the ship construction at the time. Along with that, it was difficult, therefore, to maintain their governance, ensuring that their ships were safe and they were fit to go to sea. So it was a sort of knock-on effect. In parallel to that was basically a lot of the royal dockyards and things being sold off to the commercial industry. So there's commercialization of the infrastructure, be that shipyards, ship design, and also supply chain. And then finally, there was the navies have always been leaders in technology and things, but recently the commercial shipbuilding has very much been leading that rather than the navies. The navy's still very much leading things like weapon systems and communication systems and some specialist systems, but generally shipbuilding techniques, manufacturing techniques, design of shipyards, design of engines, all that sort of stuff, it tends to be driven now commercially. So they tend to be the market leaders, design leaders in those areas. So all those aspects were sort of drivers to change, and the Navy looking at slightly different ways in which they were going to be their new ships. So in about the 1990s, we were approached to undertake initial studies to think about writing rules for naval ships. We wanted to demonstrate best practice, and they were safe, they were environmentally friendly, and they wanted to develop best commercial practices. And class seemed to fit that mold, so that's what they were looking for. As part of that, it wasn't. They needed to demonstrate internationally as well that they were fit for purpose and safe to operate, so that they were allowed to go into foreign seas, etc. Though, do navies actually follow borders or not? You could argue. There's no statutory requirement for them to be classed, but if class was going to be an effective tool for which they could use and do that, demonstrate that fit for purpose and safety, and also meet their own governance requirements. So classification, generally, commercial classification really has some rules as its basis on which sits 4 pillars of design appraisal, materials, construction, and survey. And that underpins classification as a whole. But when we had to start thinking about naval rules, we had to understand what a naval ship does. What's its purpose for? How does it interact? What's its concept of operation, mode of operation, if you like? So you have this thing called concept of operation for a naval ship. And that affects both the design and the assessment and then the maintenance of the ship through its life. So if you like, there's now this 5th pillar of concept of operation that we need to consider in classification and is therefore embedded in the naval ship rules. So, naval ships rules have, as I said, been developed over time, and they differ from the commercial rules in several aspects. Its scope is a lot wider. So, again, thinking of this concept of operation against commercial rules, we've had to increase the scope of classifications. There's a whole element that we wouldn't normally class in a commercial ship, which we are going to use classification to get that fit for purpose, if you like, for a naval ship. We'll explain that a little bit more. The other thing is this thing called tailoring. Commercial rules, the ship rules, if you like, they're a bit black and white. it's very difficult to move out of them. Surveyors don't like moving out of them. Authorities don't like moving out of them. However, the naval rules allow that degree of freedom. We actually are allowed to look at alternative approaches. We're allowed to think of adopting other standards, etc. So it's called tailoring, but there are strict requirements when we do that. We can't, it's not carte blanche to say, oh, we're going to choose this, this, and this, but nothing else. We choose the easy stuff or the cheap stuff. If you're going to deviate, there are strict rules and governance that we need to follow, and this is covered under what we call our exceptions and exemptions processes. So it's a mechanism, but we've got to still maintain that minimum level of safety. They've got to demonstrate compliance or come up with mitigation and justification of why they want to deviate. They will then propose that to us, and we will review it. Sometimes we accept it, sometimes we don't. It also, the other thing that naval rules does, it looks at other operational elements that a Navy ship does that a commercial ship generally doesn't. Things like RASO. The aspects that involve with that. Ships at sea don't like getting too close to each other. It's a bit dangerous, whereas naval ships, when it replenishes at sea, will get close to each other, and that invokes or rather brings in additional hazards which you need to understand and design into the ship's operations. Another area that naval ship rules differ is that because naval ships do not need to comply with IMO regulations, your SOLAS and your MARPOL, it is very difficult for them to therefore demonstrate some sort of compliance with those standards. And therefore the certification under those regimes makes it very difficult to issue a certificate to a naval ship. So what class does, it creates a notation that says this ship has been designed in accordance with MARPOL regulations for Annex 1 or 5 or 6, whatever. And then we can use that notation as demonstration of compliance. And then we can issue certificates of compliance against that notation, if you like. So it gives a wider spectrum in which navies can then sort of show the world, hey, this ship has been designed to meet MARPOL Annex 1, or not in the case of some ships. The other thing that the naval ships does is we're very much aware of the systems, how they interact with each other. So we're looking at a system-based design as opposed to individual items of equipment, how they interact with each other. Chilled water, is that just for cooling or is it for air conditioning, etc. So far more holistic approach. And then the big one at the end, as I said, it will allow us to choose alternative standards. And we can class against that. And we are deliberately set outside of IACS, International Association of Classification Societies, so they can't come and audit us, say that we're non-compliant. So if you like, those are some of the key areas in which naval rules differ from ship rules. I've got a couple of other slides where we differ. This next one is looking at machinery. Commercially, in the commercial rules, you're really looking at things like propulsion and maneuvering, sort of the move and float. Naval ships, we sort of look at that functionality and the hazard, that concept of operation, again, I sort of talked about at the beginning. So the way we do that, we split machinery into sort of 3 categories. We've got what we call mobility, which is your normal, moving around, propulsion, etc. That's very much like in the class side. We then look at something called ship type, which is specific systems or equipment that's there for the ship's operation. So, be it an aircraft carrier, as we're talking about that, the aircraft lifts, or the highly mechanized weapon handling systems. There could be special requirements like the LPHDs with their amphibious requirements. So there could be stability, extra stability requirements. So anything that affects that will be classed as ship type and then would be brought into class rather than maybe left outside. And then we have all the rest, if you like, ancillary systems which support all these systems. We also have this sort of in-fight function. We have no involvement with the weapon systems, and I'll show you that in the next slide. But sometimes we will, any system that supports that, again, like chill water HVAC systems, maybe lifting appliances or something like that, could support it, but has no direct effect to it. So this next slide is probably the difference. So looking at structures, first of all, very similar. Naval rules, commercial rules, very similar in the scope. The difference is some of the additional loadings and scenarios we need to take consideration of. So there are elements within naval ships that, etc. Additional loadings, the ship structure and the seats and things may be exposed to, so we need to consider that in our assessment. Magazines, explosions, etc. Again, need to think about that and how we design that structure. Then when we come to power and maneuverability, the mobility section, virtually identical. So that's your main engines, your fuel systems, transfer system, LV systems, very similar. Then some examples of ship type systems. So it could be aviation fuel. So if you're carrying aircraft, the fueling, defueling systems, the RAS, chill water, if you're, you've got specialist chill compartments or you're keeping your weapons cool. Mission bay handling systems. So a lot of ships have these, what they call mission systems and specific tasks they do. So there could be systems that operate and control that. Fresh water is also brought into the into ship type systems and is also brought into classification. And then auxiliary systems would be things like HVAC system, waste systems, etc. The other important element to think about is going back to this concept of operation. These ships are going to be operating in certain environments, and the designer will impose a series of global technological requirements or technical equipment specifications across the whole design. You know, so there'll be environmental policies, transversal, sorry. So all the equipment must be able to operate between X and Y and in different environmental conditions, often greater than the standard class rules. There'll be shock, underwater shock, air shock, EMC, and certain noise requirements, material requirements. And these will be applied transversely, if you like, across the whole design, and they've got to be considered within those rules. We then have those options like we do in all classification and the notations, but here we've got a bigger sample. So as I said, we will offer fire safety notations to demonstrate compliance with the suitable chapters of SOLAS. Or now we've got something called the Naval Ship Code, ANIP 77, which basically is a naval version of SOLAS. It's not a whole lecture of how they developed that, but if you like, but what we don't have are things like MARPOL equivalents. So we have MARPOL notations for environmental protection. We can also offer notations around life-saving, etc., escape and evacuation. So what we don't have is, or we don't get involved with, as I said earlier, is any combat systems, any weapon systems, or any communication systems, military communication systems. So there are experts out there, and we are not that. So we leave that to those SMEs, those specifics. So what about the carriers themselves? Well, this is a picture from the very start of the program. I've just we almost got something like this. So 65,000 ton displacement, just shy of 290 meters, and 68 meter beam. Those that's involved with oil tankers, yeah, maybe not, but it's still a big ship built here in the UK. 30 odd plus fixed aircraft on the hangar on the deck, 2 gas turbines, 4 large generators, and because she was designed to SOLAS, because the naval or rather the naval ship code was not mature enough, they chose SOLAS. We ended up having to have an emergency generator on board. If you go to most naval ships, they don't have emergency generators because they've got excess generating power capacity. But in the carrier, we did. So in 2009, Lloyds Register signed a contract with the Aircraft Carrier Alliance. It was the largest contract we'd ever signed. It was also one of the longest, which is probably why it was so expensive. 9 years. We used 18 surveyors over 6 sites around the UK. I think we used more than that, but we got up to 18 at one particular point. So the Aircraft Carrier Alliance were the alliance that were tasked, if you like, for designing and building the carrier. And many of you, I'm sure, know it. It was an alliance between Thales, who were the designers, BAE Systems, who led BAE Systems and Babcock, who sort of led the build elements, and then the mod DES, that were, if you like, effectively the owners and the clients. So it was a project of firsts. As I said, it was the largest naval contract Lloyd had signed. It was actually the largest marine contract we'd ever signed. It was the longest in duration, and it was the first ship that we were going to build to Lloyd's naval machinery rules. One of the biggest ships that the Navy built, and it was the first time they really built with an alliance rather than direct straight from the mod. So Queen Elizabeth steel cutting was in January 2009 with sea trials some 8 years later, and then acceptance into class in 2018. Prince of Wales effectively followed 18 months behind, sorry, 2 years behind, but did sort of kind of catch up a bit at the end. So quite a length of time. Built in 6 locations, or the steel units were built 6 locations around the UK, including here in Merseyside, and then assembled in Rosyth in Scotland. In terms of the equipment and components, actually, it really was a UK-wide project. I think, if I remember correctly, I think there were only 3 regions in the whole UK that didn't supply any kit to the camp. So it really was a UK-wide project. And as I said, this is just a very quick sketch of the block breakdown, and really just included the MLAs we're involved with, which was obviously a bit of local interest, which were what they call the center blocks, so CBO2 and CBO4, yellow and orangey. So quite a bit in terms of it, and there's some good photos of the team that built it. I spent many weeks and months down here looking at some of this stuff, supporting the local surveyor. These were some of the CBO2 from Queen Elizabeth being delivered. So, what was some of the earlier work? Well, the carrier had a long development phase. It was almost 10 years in itself. So there was an initial assessment done way back at the beginning of the century. There we go, where we had 2 designs, BAE design and the Thales design. And one of the requirements was to have basic LR, what they call approval in principle. So we were asked to assess these. They went through then the initial gate in 2003 when the Aircraft Carrier Alliance was formed, and then the design really started in earnest with Thales having won the design the design competition. So it was the Talus design. So there was an awful lot of design assessment that had to be done. And again, LR was there supporting the carrier ACA throughout this, looking at all sorts of things from fatigue assessments through to, we had embedded people in their design teams, so we could advise there and then. So there was a lot of work that was carried out. Then we were brought in for machinery in 2006, and then in 2007 we really started plan approval in earnest, having done a lot of the assessments and analysis and things. So there was a lot of work really even before we started getting involved with plan approval. So what were the notations that were chosen? So notations, if you like, are the flags that are used to identify which bit of the rules we are going to apply to the ship. Fairly standard, but basically 100A1, she's built under special survey, under survey of Lloyds Register to Lloyds rudder and anchoring requirements. She has she's classed as an aircraft carrier, obviously, with an air notation enabling her to carry out air operations on her deck. She has a worldwide service, and she has enhanced scantlings. As was sort of kind of shown in the previous slide, there was a lot of work done over the residual and extreme strengths. So those notations were awarded, as well as the standard structural and fatigue design assessments that were carried out. And then obviously we had construction monitoring to ensure that the ship was built to those design design standards, if you like, to match the model. We have lifting appliance notations. There are 40 lifting appliances on the carrier, in excess of 40 lifting appliances. When you start adding up the aircraft lifts, the ship's lifts, so it's got about 7 or 8 different passenger lifts and store lifts inside. She's got davits for rescue boats. She's got cranes, engine room cranes. So as I said, about 40 odd lifting appliances in there, which was a nightmare. And towing, GA. NS refers to, is a trigger to tailoring. So anything that's got an NS, that notation was tailored. So these is showing where we have deviated from the rules. The tailoring document would define that. We then have the military distinctions, military notations rather. We've just got a flag to it, MD, but behind that there are classified notations that refer to certain elements of analysis that we carried out. Said anything that could be from to shock to small arms to blast, that sort of information, but we don't sort of declare that because for obvious reasons. And then machinery class, we have the standard Lloyds machinery class, again built under the survey, tailored. We had the central control station. We had PSMR star, which basically just means we had 50% redundancy in propulsion and steering in separate compartments. We then had the MPMS, MCM, and RCM, and I always forget what they all mean, but they're all to do with condition monitoring for the machinery through life. In the end, those were dropped because it required input from the Navy to develop their planned maintenance schemes. The Navy used their own system called UMS, some of you may be aware of that, and in the end they decided they want to follow that rather than develop a new whole system under these notations. So in the end, those 3 weren't actually awarded. We then got the RAS notation, so this is replenishment at sea to enable the ship to replenish a beam, stern, and from above. And that also includes things like communication, etc., and also the wiring system that goes between the 2 ships. We had navigation and integrated bridge. So a lot of the navigation equipment met the rules and requirements, and integrated bridge for communication and steerage. Lloyd's machinery, Lloyd's maneuvering assessment. So The capability of the ship, turning circles, etc., were all assessed compliant with Lloyd's rules. CPAC is the noise and vibration annotation. So the ship was assessed to for noise and vibrations internally and externally for compliance. And then we had the EP notation for environmental protection with enhanced requirements around anti-fouling, ballast water, grey water, and refrigeration. Again, unfortunately, refrigeration got lost because they wanted to use the older, was it 310, the 304, isn't it? A or something, rather than the more environmentally friendly one. POL, it means it's compliant with MARPOL Annex 1, 4, 5, and 6. Interesting, we had to declare the steel cutting of Prince of Wales very early, so it didn't have to comply with MARPOL Tier 2. And then we had the fire notation to demonstrate it's compliant with SOLAS for structural fire protection and fire detection and extinction as well. So, classification is a cycle. We obviously have the rules in which we then do the design against. We then build the ships. We have the as-built ships. We then have in-service and research, plus feedback and lessons learned, feeding back into the rules. So the rules are always in this continuous development stage. So it's always it's difficult to start the project to understand which set of rules we are going to use. Naval ships have got a particular problem, is they take a long time to design and they take a long time to build. So it's always difficult trying to determine that starting point. However, in this project, we ended up using the 2005 rules. So the baseline was naval ship rules for 2005, and that was the ship and the systems. What was agreed, and which is where some of the tailoring came out, is because naval rules were fairly new, agreed that some of the equipment could be procured and built under the ship rules. But they had to be aware of some of the tailoring. An example of using tailoring, if you like. Lifting code was 2003. Then we had these two tailoring documents, one for machinery and one for structures, which highlighted where we deviated. Well, deviate is the wrong word, is where we chose a different rule or we mitigated any rules that where we were sort of non-compliant. We then had the classic construction and test and inspection plan, system list, identified the certification requirements for each of the components. And then obviously we had the contract in which we carried out the plan approval. So the plan approval stage, we had 2 or 3 submissions and we had managed to complete the first and second set before we started building, but there was still change during build of the first ship, so we had to the other thing we did was it was identified that it would be a good idea to do what we call virtuous surveys. I think it's very well established now, but back then we were keen to do this. So this gave the opportunity for the to walk through the 3D model virtually and try and identify all those build issues that that you would. I'm going to make you Duncan. Misalignments, single-sided weldings, inaccessible areas, all those sort of things that you pick up as a build surveyor. But some of it you can do it earlier by going through this virtual survey. So what we did is that we split it into groups, and the surveyors, site surveyors spent, before we even started cutting steel, going through this model virtually and basically doing a normal structural survey and coming out with comments and things. It proved really quite useful. One problem was that, as you can see in some of these drawing, only the major penetrations were in, not all the minor system penetrations. So we still ended up finding lots of issues during build, but the attempt was there, and it's now been adopted in other projects as well. Naval projects, we're doing these virtual surveys. That was a nice little lesson learned for that. Okay, just a little bit about the design itself. I've nicked this from the ATA, so. The interesting bits about the design, the structural design. So 90% is DH36, but it has the flight deck is enhanced for basically the loadings of the aircraft landing on there. There was also quite a bit of cold weather capability it needed to maintain. We had the notation of worldwide service, so there was quite a bit that requirement came into it. So again, a bit of a driver for some of the material standards, and then they used mild steel grade A where they could to try and keep things like some of the costs down. Fatigue life, the FDA, SDA was aimed for 30 years, but with an aspiration of 50, and almost got to the 50, so it's quite good. Predominantly transversely framed and with longitudinal stiffening and bulkheads every 13 meters. So not particularly unique design, fairly standard, I think, but it certainly was effective and straight. I know, it was actually fairly straightforward to build. We did all the usual analysis earlier on global and local loadings, and as I said, all the SDA stuff. The ship's life, and identify build and construction monitoring. The other interesting aspects, one interesting area is classic midship section. It's got a big hole hanger, and we've had container ships around for a long time that are missing the whole deck. They approach the design in that way, box girders, etc. Carrier decided to choose the American system of this bent bulkhead, B-E-N-T bulkhead, which is effectively a large girder made up of a deck and interconnecting a vertical bulkhead in between, and use this as a system for maintaining the strength, if you like, of the ship's structure, especially longitudinally and transversely. But that required an awful lot of analysis to make sure that there was not going to be any issues with the design in service and things. So all sorts of finite element was carried out and assessments were done against the rules. So yeah, that was quite interesting. It was a little bit before my time, but so because that was done during the plan approval. But it was interesting trying to ensure that build was done. The thing is, though, that those big bent bulkheads, if you like, the sort of glorified girder above that spanned the top, was where all the passageways went, the systems went, the corridors on the ship for all the systems. So we had to control the number of openings that could be put in there, or else obviously you'd be weakening that sort of girder effect. So an interesting development there, using an old design, but in an old method in a newer design. Another interesting thing, burst fix. Now, some of you may be aware of this and know some of the issues and the problems we had, but there was a lot of assessment done before we started building, looking at previous ships. Decided that something that could help with outfitting was something called fix, this stud drilled stud well to fire in, to basically, rather than a welded stud, for hanging systems, so to hang all your cables, your pipes and things off. But this system obviously required a drilling and then the stud that was fired in for friction welding. So everybody was kind of nervous from it, from a structural aspect. What was the effect going to be? So a lot of study was done, lots of mock-ups were done, lots of testing was done. So we looked at fatigue, we looked at corrosion, all sorts of things in all sorts of structures, locations, etc. And we developed a rule set. On paper, it worked fine. It passed all the tests that we needed, etc. However, we had to have a series of guidelines. But trying to keep 1,000 or 10,000 workers, those guidelines proved a problem. Yeah, it was a nice idea. I think people looked at it. You did see the advantage was that you could do that after you painted it. You just drilled the hole and fired the stud. Whereas traditional outfit, you've got to, because it's welding, you've got to do it before you do the painting. But it was a moderate success, but it's not been adopted as some of the other newer projects, but it was a nice little site. Okay. The build, so sort of my element. How was Lloyds Register going to build these ships? Sorry, we were going to build surveillance of these ships. Well, the ACA and the Navy really challenged us. They said, well, this is your biggest ship you've ever done, etc., etc. You can't use normal classification processes. So we agreed, and we said, right, then we will project manage this, the build, just as we would do a large offshore project, like how we would do any other large build project. But so we adopted the government's recommended project management system at the time, called Prince 2. We also sought guidance from other offshore projects, large projects, and other industrial projects that we were doing. So project management, predominantly, we had project plans, communication plans, safety plans, as well as all the profiles, registers, issues logs, change logs, goodness knows what. Hence why you needed a permanent project manager. So he wasn't doing any surveys, I was managing this lot. So it was a deviation, if you like, from the way we were normally doing things, but on a project this size, it really was beneficial. We also heavily relied on how we deliver assurance. We do it very much on a risk-based scenario. So anything that we class as high risk is of importance, is essential to class. We will do the one-on-one direct inspections, and we will look at that, and the surveyor will be there. He'll witness it. He'll sign it off, etc. And then obviously we will pull back based upon what that particular risk is, be it function, mishap, or whatever. Ultimately to doing just patrols and audits in some systems. So fairly well known and established sort of way that we do surveys. But a lot of people seem to think that we replace quality assurance when it's the exact opposite. We rely on the shipyard's quality processes. Class doesn't exist unless there is a robust quality QC and QA process. We need that, or else we're starting to, we've got a risk there if you lose that whole bottom of the pyramid. So we need to assure ourselves that quality process is in place. We do that through a series of audits and reviews and things. And if you like, that's the concept in which we use class. How we then decide what we want to survey. We then take that philosophy, right, and then find what we are going to survey. So we developed the construction test and inspection plan, or the IPT, as a lot of people, the inspection and test plan. For some reason, We very much looks at the systems, looks at the notations, looks at us at that risk, etc. We decide what we're going to see, what we must see and sign off, what we will go and witness, what we will just patrol, and what we will review. Fairly standard and well established, but on this project, large scope, this became a document. That was then fed into the shipyard's completions management system, which then identified when we were called for survey or sent stuff for review or something like that. This really only dealt then with the inspection elements rather than the test and commissioning elements, which was captured separately. The typical surveys that we did on the carrier: dry survey, the steelwork, dimensional control, and NDE review, hot work, so all the pipe connection, pipe fittings, your classic air tests and water tests, including leak tests for things like your spills, your CBRN requirements, things. Behind linings, something a bit unusual. Behind linings, just for those that don't know, it's just an inspection before the structural fire protection. Sorry, it's before the sort of carpentry lining goes up that makes it look nice. So we just need to check that the steel works there, the structural fire protection is there, all the penetrations are in there for water tightness and fire, etc. So the structural fire protection, lifting eyes, watertight integrity. We spent a lot of time doing watertight integrity because we were the recognized organization for the Naval Authority who were responsible for watertight integrity and stability. Doors and hatches, a lot of time doing doors and hatches. The other classic inspections, pipes, inspection and testing, HVAC systems. We looked at all the HVAC ducting for compliance for fire and watertight integrity, chilled water systems, the classic mechanical installation of machinery, gas turbines, diesel generators, etc., shaft line, rudders, stabilizers, chocking and alignment. Mission systems, that's just a fancy word for sort of combat systems, and the only involvement we had was broadcast and alarm and self-powered telephones. That was about that's the only thing we touched on that. And then the classic control and audits on all of that. And just a reminder, we had to do all that against the rules, but also against all the transversals. So when we were inspecting a piping installation, we'd have to think about shock, the pipe clearances. We have to check that the materials were compliant. We have to check it had the right IP rating. We have to look at human factors, etc., etc. So there was a lot of things you had to think of in addition towards as well as the normal class requirements. So as well as all these inspections, we had all our reporting to do. We had to review test reports, sign them off. We had to deal with non-conformances, the ones we raised, and then the clearance of them. We had to review all the test forms for commissioning, review and accept before we went to commissioning, and then we had to do all the commissioning. We had a whole pile of project reports that we had to do for, be it for quality, for production, for governance, for commercial reasons, etc. And then the interim certificates and things towards the end. But again, this is where we were challenged by the Navy. They said, how are you going to get 14 surveyors to agree to something? Surveyors are classic. We're trained to be individual, free-minding thinking people. You put two surveyors in the room, they come up with a different idea of whether something's acceptable or not. Or so the client thinks. So we had to demonstrate to the Aircraft Carrier Alliance that no, we would actually approach this as a unified body. So we signed the project with technical leads. So we had a lead structural engineer, mechanical, electrical, and statutory fire. And then so they were responsible for that particular element of the build. And then we would hold regular workshop training sessions both internally and with the ACA. We put a lot of project processes in place. I don't know how many project reports or project guidance information I had to write. It's like writing the SPM all over again. But we had to do that. And then we had lots of audits, including the Naval Authority audit as well. So we always had somebody looking over us. So that was a challenge as well. And yeah, I just threw in the ACA wanted to see what we did on a patrol. So we developed patrol checklists. How you see all over the place. But, thanks. We do that. Reporting. It was a big project. It was very difficult to control. The shipyard had this completions management system, but it's very binary. It was either accepted or not accepted. It was very difficult to see how progress was doing. So we developed engineers and especially Lloyd surveyors. We like Excel spreadsheets. Well, I don't know my random. So develop things like heat maps and things, trying to understand how we were progressing, what had been signed off, what was outstanding, etc. Needed it as well to manage the whole team, because obviously I had a budget and everything to follow. Okay, commissioning. How am I doing for time? Almost now. Okay. Commissioning. So we built the ship. The ship's gone live. We've gone LV. We've got HV as well. So we've obviously, the way they broke it down is between harbour acceptance trials and sea trials. So harbour acceptance trials was obviously all your classic requirements. There was over 200 test forms that we had to review. I actually think in the end we only had involvement in 180 of them. But that just shows the number of systems that we were trying to commission or had involvement with. So it included everything from power and propulsion, platform, which was would be things like gear HVAC systems, etc. Lifting appliances, I said we had 40 lifting appliances. Aviation, so that'd be like your fuel transfer systems, your fueling, defueling. This aircraft have they're a bit like plug and play. They've got a little charging cable you've got to plug into the aircraft, but they're all different voltages, funny voltages. So we had to, we had a whole pile of electrical systems for charging those that we had involvement with. Communication and navigation, so your navigation equipment and communications, GMDSS, etc. MARPOL systems, fixed firefighting systems, highly mechanized weapon handling system. So this is this system that's completely automated. Press of a button, it brings missile A from point down in the hold up onto the flight deck, and it's then put on the aircraft. So it's a whole automated system there. And really, we ended up having to have dedicated teams looking after these systems, because it was very difficult for somebody just to jump in and out from one system to another, etc. So we had to have dedicated teams, and yeah, there were a lot of long hours and things. As usual, dates would come up and they'd be scrambling around to finish in time to be able to go into sea trials and things. So, said a lot of work on commissioning, and you can see maybe why it took so long with so many systems. Sea trials. When we got to sea, there were over 30 different sea trial serials we had to review and complete. We spent long periods at sea. Elizabeth had 3 individual sea trials. I think the first sea trial was 3 months, and then it went to a month, and then it went to a couple of weeks or something like that. And that was a challenge in itself. And maybe the well-documented problems we had on the BBC program you saw. It was all interesting stuff. Prince of Wales, we had learned lessons by then, and we managed to get sea trials down into 2, just I think it was 8 weeks or so. So that was a big improvement. I only needed to do 1 sea trial. the ship was in and out of Invergordon because it was the easiest place to get deep water anchorage alongside. And out into the test area. The carrier was only allowed a certain area in the North Sea to do its trials because of its natural interest it was obviously there. We had a box in the North Sea that we had to stay in and then we had to stay out of. Because it had such long sea trials, we had 3 to 4 people on the ship rotating on and off all the time. I had about 12 people in that rotation, going on and off, on and off. Sometimes by boat, sometimes we walked on and off, sometimes we flew on and off by helicopter. And yeah, as I said, as you can see with Queen Elizabeth, we had real challenges in the first sea trials because a lot of the systems were new to everyone. So as well as being there for survey and testing and commissioning, we were there to provide support. We were to supply support for things like the quality forums, build assurance, but also to review change, technical queries, be part of working groups, getting the ships ready, be it for sea or for launch or whatever, part of test groups. So a lot of our time was actually spent doing documentations as well, so it wasn't just pure survey. And then the usual deliverables. One of the unusual things for Lloyds Register is we have to issue a certificate for sea trials, which is a bit difficult because we go to sea to complete things in our mind. So we end up having to give a statement of where the ship is, from anything from watertight integrity to structural fire protection completion and all that sort of stuff, and say that we don't think there's any issues stopping it from going to sea. The usual progress reports, key performance indicators, loads and loads of certificates. It took hours writing the certificate. That's the end. And as I said, we also have to issue reports for the Naval Authority for their final naval ship safety certification at the end. They're effectively the flag state there. And then that's just, I think, Nick Brown, our now CEO, handing over certificate there for Queen Elizabeth. When we surveyed the wardroom, it didn't have any of that wood in it, honest. Okay, so we had all this documentation that we then had to bring together. And we had all the drawings, all the design appraisal comments, we had all the equipment certification coming on from all the suppliers. We had this massive amount of survey work and test forms. We had a whole pile of deliverables we had to bring in from the other shipyards, etc. We had all the decision and production queries to review, test forms, sea trials, and we had to bring it all together. And it's the bane in the life of a new construction surveyor is that they seem to be the tail end Charlie. They have to bring everything together and make sure it all fits in nicely and we've not missed anything. And when we think it's all well and good, we can then hand it over to our first entry group recommending the ship gets classed. Now, he said normally you would do that. That would be just done by a couple of people, but because of the vast amount of information there, we had to again split it down and each person focused on their area. And then it was sort of brought together. I would package it all up and we would then manage it through first entry, and we'd also have a surveyor there helping with the that element as well. So there was a lot of work to collate it, a lot of paperwork generated out of this as well. So the normal Lloyds processes didn't naturally fit that. Okay, that really sort of finishes the classification for build and plan approval build. I've got an element of supply chain, which is a big lessons learned we've come out of this project, which I can go through as well if you want. Carry on? Okay.
Yeah,
all right. So as I said, the supply chain is a massive supply chain. And if we again look at this classification sort of cycle, and the bit that comes into the end is the equipment component certification. And in commercial shipping, it's well established. The shipbuilder knows who they're going to go to supply generally, and the supply industry knows what classification is, what they need to do, etc. In the naval supply chain, there's an awful lot of suppliers that haven't dealt with normal classification very much. And there's an awful lot of confusion that goes around, especially when the shipyard just asks for something that's Lloyd's, deliver equipment A with a Lloyd's certificate, so what does that mean? Lloyd's doesn't help itself very much because we have lots of different. So if you like, in terms of certification and assurance level at the design and manufacturing, there's lots of different ways. We've got type approval. We could design appraise something and then build under survey, etc., etc. So there's different ways. Now Lloyd's has adapted to meet the industry. It isn't the case that Lloyd's has said this is the way you must do it. We're adapting to the way the industry wants to design and build things. Hence why there's so many different ways. Plus, we've got, as I said, all these transversals. We've got all these requirements that this project has applied to all its equipment that could be specific to the project, and it's on and above normal class requirements or even defense standards or whatever. And then we've got this tailoring where we're sort of picking and choosing which rule set we're going to do. So we're not going to necessarily procure an engine just to Lloyd's naval ship rules. As I said, we're procuring to the ship rules, but we actually want a certain depth. We're going to use a defense standard over things like power supply to that. So it's got to have cabling of a certain requirement to it. And we're going to have another requirement that means it can be flooded to a certain level and all this sort of stuff. We start adding on all these little bits. And it can confuse the living daylights out of the supply chain, confuses the shipyard trying to design it, and confuses the surveyor. So how do we make sure that when the surveyor goes to the place of manufacture, what they're going to look at, what's the certificate type of certificate? So we've developed these things called product work instructions, which is a guide to the attending surveyor that when he attends a certain manufacturer, he knows what rules he's going to do, what additional standards, what's been tailored, what are the transversals that are applicable. And it's meant to help them, and it was predominantly to help the surveyor. We have since learned that we actually need to help the supplier, and we even need to help the ship designer as well in trying to understand this. But in the carrier project, we specifically written with the surveyor in mind. So that's what we were trying to do. But I suppose the easiest way to do it is component. Now, this is a gearbox. It wasn't a gearbox because we don't have one. But if you had a gearbox, it had to be design appraised. It has to meet Lloyd's rules. So there would be design appraisal that would be carried out on it. And the design appraisal documents issued, maybe in particular design requirements or survey requirements added. The surveyor then needs to come along to do the survey inspection of the individual components while they get built. And then he's got to be thinking of the materials. They need to comply with the rules. So in a gearbox, you've got the pods, you've got the gearing, the teeth, the camshafts. You've got the lube oil system, piping systems, you've got the electrical system, the control systems, all needs to comply with Lloyd's rules. So it's all doing when they're building. So that's all part of the design. As I said, you've got all the components, the pumps and things. So some of those pumps may need to come in with LR certificate. And again, if they may, equipment will come with MED or type approval. may require, and we're needing to verify compliance for the standards. You then may have things like certification and type approval for that, or maybe not. Maybe you've got a control system that's got a certain level of software integrity, and you've got other all sorts of bits and pieces with and then the poor surveyor that's needs to review it all, and if he's happy, give a certificate. So there are a lot of components there. The piping system might have to comply with a certain shock requirement. The material may need to comply with this, again, another certain requirement. So there's a lot of things that you need to do to be able to control and understand all of that. And I said, it gets quite a bit of confusion. So we've got lots of types of certificates we can issue. So there's a whole pile that we can issue, and then there's a whole pile that we don't issue. Some will accept, some will not accept. I won't go into detail. Just there for an example. So when a technical equipment specification is issued, it just says, I want that certificate. You understand why there's going to be. Also doesn't help now that we don't, the UK Navy doesn't need to comply with MED rules anymore. That's another interesting change, thanks to Brexit. So what we've discovered, lessons learned, if you like, we need to be, equipment certification is always traditionally checked by the bill surveyor when it arrives in the yard. But often that's too late. We're finding certificates that are not suitable for ship. I've even seen a certificate bottom not to be installed on a but the surveyor at the place of manufacture was asked to issue a Lloyds certificate, and he says, well, it's not compliant. I can't issue, it doesn't comply with the rules. He says, well, it doesn't matter, just issue me a certificate. So he's issued it saying, this is what I did, this is what I tested, but don't put it on ship. So you've got to be always checking that. Now, the shipyard just sees a Lloyd's logo on the paper and goes, hey, you've got a certificate. Materials, we've had real problems with materials and making sure that they're compliant. Another thing that we found is certificates would come in with lots of outstandings or exclusions on them. So especially on some of the carrier, a lot of the kit was too big to be fully tested at the factory. So it came with a whole pile of outstandings. And then we had to capture those outstandings and make sure they were then put in testing and commissioning forms to make sure that that was all captured. So that was another whole element of review that we had to do. Some came even with defects on them that were written because they had no time because they had to meet delivery dates. And then it was a case of getting the certificates. Again, with all these certificates coming in from all over the place, how do you get hold of them? How do you make sure that, because they don't come to the bill surveyor, they get issued by the Lloyd surveyor to the manufacturer, who then passes it on to their client, which is the shipbuilder. And then how do we make sure we get hold of them? So large data, we can imagine these things and databases and the map certificates flying around. And then trying to make sure that originals like anchor chain kept on board and things like that. That was, again, something simple like that was a nightmare. So a lot of issues. So if you can imagine the supply chain life cycle, so early days, the ship says, this is the requirement I need for this bit of kit. These are all the tailing and the requirements, etc., etc. Send it out for request for tender for the suppliers to then bid for it. Then goes through the system. Then they get awarded the contract to build the equipment. Lloyds will attend or not attend. We'll do plan approval, attend, witness things if you like, and then it's delivered and integrated and shipped and tested at the ship. Additionally, we would be involved as a shipyard surveyor in item C, area C. But what we learned from the carrier, we had to try and do it item B. But what we've actually since learned is that we need to be involved at A. We need to involved in naval projects really when the technical equipment specifications are being written by the ship. Identify the right material requirements then to try and de-risk all these problems we found certainly in the carrier. So, in summary, the carrier, we saw or probably approved over 500 plans. We issued certification for about 4,000 individual items of equipment. Did hundreds and hundreds of patrols. We did 24,000 direct inspections, be it a dry survey or a structural fire protection or a pipe test. The pipe test were in the QEC whole ship inspection. So that's part of the 86,000 inspections. So that's pipe inspection, testing, HVAC testing, inspection. We did 180 test forms, 30 sea trial test forms and 3 sea trials. And we reviewed over 1,000 change requests. So that's what took us 10 years. And ultimately we classed the ship. So, thank you.